Okay, welcome back class, and now today we're going to start talking about derivatives. Okay, and we're going to define the derivative, and we're going to start by going back and discussing the tangent line problem again. Okay, so to start with, I drew this graph, and what we have is we have a point, and let's say we want to find the slope of the tangent line at this point. How are we going to do that? Well, before we get to how, let's start with the secant line. So let's estimate or approximate the slope of the tangent line by using a secant line. And so we can take a point, let's just take some value of x, somewhere, some distance from A, and we'll take a point at there on the line, and we'll use the secant line to estimate the slope of the tangent line by using the slope of the secant line. So if you remember, the slope of the secant line was given by this formula. So here it's going to be the difference in the y's divided by the difference in the x values, the x coordinates. So in this case it's going to be f of x minus f of a over x minus a. Okay, so that's the slope. Now that's one form of the slope of a secant line. So now what I'm going to do is let's redefine the slope of the secant line by saying, hey, instead of using x, we know that this distance, let's use this distance here away from x. Let's call this distance h. And at this point over here, really, instead of using x, let's call this some distance away from A. In fact, this x value would actually be equal to A plus h. And so this point up here could actually be represented as what? It'd be A plus h, comma, f of a plus h. Okay? So if we use this notation using h instead of x and a, then what will happen to our formula? So in this case here, what will happen is the numerator will become f of what? F of a, or excuse me, hold on. F of a plus h minus f of a. Right, so all we're doing is substituting for x, right? And so x here is going to be what? It's going to be a plus h minus a. Well, what happens here? The a here and the a here cancel each other out. They're subtracting out. So a minus a is 0. So these go away, and we end up with this formula for slope. Okay. Now, what happens if we take subsequent points on the graph closer and closer and closer to our point that we want to find the slope of the tangent line of? So what happens if I was able to take this and slide it down slowly? What would happen? The secant line would change, and the slope of the secant line will also change. And as you get closer to this line, the secant line is going to end up on top of the tangent line. So it seems as we get closer and closer and closer to this point, the secant line gets closer and closer to the tangent line. So that means if we're able to decrease the distance between x and a, or in other words, if this distance gets smaller and smaller, this slope formula gets closer and closer, giving us the slope of the tangent line, right? And that is the essence of what we're going to call the derivative. And this slope formula we are going to call the quotient. Okay, what we call the difference quotient. Okay, and so in the next video I'm going to introduce the definition, and then we're going to do some examples. Okay, see you next time.